Hello everyone, welcome back to my YouTube channel. In today's video, I will make a tutorial how to use Icepak. And this is the problem from my online test in practice of thermal management engineering subject. Problem description. The cabinet contains a PCB or printed circuit board, a source, 4 heatsinks, a 3D fan and a grill. It is anticipated that the flow will be turbulent. Okay, the first step, we have to start an ANSYS Icepak. We can see here. And then click New. We have to give a name of Sharina work. Okay, and then create. And then we can see this is a cabinet. And then we change the view become asymmetric view like this. This is the model of cabinet. And then we go back to the file. And then in the basic parameters panel, select turbulent as the flow regime and keep the default zero equation turbulence model. Back again. Open basic parameter. We have double click basic parameter and then we have to change the flow regime into turbulent and zero equation. And then click Accept. And we go back again. Select the cabinet in the model tree and specify the following in the object geometry windows. We change the geometry of the cabinet. Okay, double click cabinet. We can see here, or we can click the cabinet and then click this one. It's the same one. And then we have to change the value of geometry. 0, 0.2, 0, okay, 0, 0.2, and 0, and then 0.2, 0.3, 0.2, 0.2, tap 0.3, tap 0.2, and then update. Look, we can see the cabinet becomes small, and then we can see the isometric view like this. After that, we click done, and then for the next step is click on the create PCB icons in the model toolbar and create a PCB and double click, and then we have to edit the PCB. Okay, we have to go back to Icepak. Then we have to looking for toolbar how to make a PCB here. Okay, this one is PCB, and then double click in PCB, or you can click here to edit the object and then change the geometry following this. But in ZE there is no size, so we have to change the plan. This XY plan, there is no ZE, I mean. Then go back 0.06. Have to memorize it. 0.06, 0.2, 0.125, and then XE is 0.14 and 0.25. Okay, it's right done. And then after that, rack specification number in rack is 4, rack spacing is 0.0125 meters, and the total power is 8 watt. And then we can go back to properties tab. Number rack is 4, rack spacing is 0.0125, and then total power is, I forgot, 8 watt. You can change this, update, and done. You can see this is the PCB, and for the next step is create the grill. Enter the following coordinates, and then we have to create the grill in Icepak. This one is grill, right? And then we have double click grill, and then we can see we have to change the geometry following the tutorial. there is no exit size, so it must be YZ plan. And then go back again, we have to see the coordinates of the grille: 0.2, 0.2, 0.08, 0.2, type 0.2, type 0.08, and then 0.3 and 0.18, 0.3 and 0.18. Update. So they're in the side, and there is no more. We have to click done here. Next step is create the source. Enter the following coordinates, and then the total heat is 1 watt. Okay, source, it must be this one. And then double click, and then we have to change the geometry. Following this, there is no YE size, so it must be what plan? We have to find out. It must be XZ plan. And then 0.07, 0.2. It must be wrong or not. I don't know. Oh, it's right. And then 0.13 and 8. 13 tab 8. Is it right? Yes, it's right. And then don't forget to put the total heat is 1 watt. Update, and done, and done. Okay, next we have to create the heatsink. How to make the heatsinks? We have to create a new block, and then the shape is cylinder and the plan is XZ. And we go back to the Icepak. Create the block. Where is the block? This one is block. And then this is cylinder. The geometry shape is cylinder, and it must be XZ plan. And then we have to see the size of the heatsink: 0.085, 0.2, 0.085, 0.85, type 0.2, and then 0.035. You have to cross check this again. Don't be wrong. And then height reduce and reduce to 0.05, 0.01, 0.05, 0.05, 0.01, 0.005. I don't know if it's right or not. Have to check. Okay, it's right. Then we have to change the thermal specification is to pure. Have to go back to properties tab, and then under the thermal specification in solid material, we have to find out Q pure, C pure, K Q true, Q pure. This one. Okay, and then copy the first heatsink to create the second. Okay, after this all finished, click update, and done. And then we have to click this and then copy object, and then copy the first heatsink to create the second. Okay, but this means that number of copies is 1, and then translate, which is it shows the location of the heatsink in what position. It's x 0.03, 0.03. Apply. It's done. And then select both heatsink and copy. Okay, select both heatsink. Click Control and select both, and right click, and then copy object. Copy. Okay, and then translate. Z 0.03, 0.03. After cross check it again, and then apply. We can see it's done. Next, we can see that there is 4 block as a heatsink with cylinder size. Cylinder shape. And then what next? We have to see create the fan. Okay, how to create it? Okay, next step. I'm sorry, there is a trouble with my recording. And the next step is create the fan. How to create the fan? We have to choose search fans conditions with minimal fan size 10 millimeters, max fan size 60 millimeters, minimum flow rate is 50 CFM, and select delta FFB. And then we have to back again to Icepak, click libraries, and then right click and search fans. And we have to input the minimum fan size and maximum fan size 10 and 10 and 60, okay, millimeters. 10, that's right, and 60 millimeters. And then thermal flow, minimum flow rate is 50 CFM. You have to see and cross check again, and then click search. You have to search for the fan, and click delta FFB 061224EHE, and then click create. So there is a fan, and double click fan. We have to change the geometry to set the position of the fan. And then we see XC, YC, and ZC, ZC, and then we have to input 0.23, 0.05, okay, 0 and 23, 0.0. Is it correct or not? I have to see, okay, it's too much, 0, update. And then if there is a warning that the object is outside, right click cancel. We have to change the plan. We have to change the plan YZ. Okay, we have to choose the appropriate plan. This one, YZ plan. 0, 0 0.23, 0.05. Update. So this is the fan. The fan, the blade fan must be on the outside because it will flow the heatsink in here. So it makes the heatsink become cool. Like that. And then done. And then we have to go back. Create assembly. Select the source and 4 heatsink, put them into assembly. Okay, source and 4 heatsink, click and control, click, right click, create assembly. Okay, we can see the assembly here. And then turn on the mask separately option and enter the following select parameter. And then click, right click in here and edit object. We can go back to, we can see the meshing tab. Turn on the mask separately, and then you have to input the size here. Okay, 0.01, 0.01, type 0, type 0. It must be 0, another point. It's 0, 0.01, type 0.01, type 0.01, type 0.01. Update. Continue. No problem. Okay, it's right, 0.01. Okay, everything is right. Oh, this one, I know, that's wrong. Okay, update and done. And then go to step 12, general mesh. In mesh control, set max X size, Y size, and Z size into 0.02. Okay, we can click here, or we can click in here. Model, generate mesh, it's the same. 0.02 max X size, Y size, Z size, and then mesh parameter is normal. Turn on the mesh assembly separately option and generate mesh. Okay, turn on mesh assembly separately. This one is must be normal and generate mesh. Okay, it's done. If there is, we can try again, and then we have to see the display mesh, surface, plan. We can see the mesh and the plan location, the plan by plan location. You can see all the results of the mesh. In the set option drop down list, select Y plan through center. It's right, Y plan through center. And then what's next? We have to see change to isometric views. Okay, then we have to inactive the display mesh and close. Next step is change the number of iterations to 200. Enter 200 in the number of iteration field. Okay, we have to go to solution setting and basic settings, and we have to change the number of iteration is 200. 200 accept. And then what's next? Drag PCB source and Grille into the points folder. Right mouse click on the Grille in the points folder, select edit info and the select temperature and activate the velocity. Okay, PCB source and Grille. PCB Grille source, you have to drag it to the point. Okay, what's next? Right click mouse on Grille. Right click, edit info. We have to turn off the temperature and change that into velocity, and then accept. It's really easy, right? And then run solution. Click on the start solution button to start the solver. While iterating the solution, two new windows will pop up showing convergence history, print convergence, and temperature monitor. Okay, we have to print this because it must be as our report. So, and then solve, run solution. But before that, we have to check the model first. You can click this, or model, check model, or both. They are both same. And then solve, run solution. Okay, start solution. After the solution is done, we can click done. And then what's next? Create plan cut. To create a plan cut, click the plan cut icon in the shortcut toolbar. In the set position drop-down list, select Y plan through center. Turn on the show factors option, click create. In the orient menu, select isometric view. Okay. Sorry, plan cut. We can see this plan cut, or we can see in here plan cut. But it much easier in here. Y plan through center. I'm sorry. Y plan through center. Show factors and click create. Show factors, click create. Wow, amazing. Then parameters, we have to calculate in this object only. Apply, done, update. So this is the result of the velocity of the fan. We can see we can see the highest velocity, of course, from the fan, and then the fan is flow through the heat source, heat sinks, grill, and PCB. We can see all of the value here. And then after that, we turn off the active option, and then done. What's next? Next is display contours on temperature for the solution. To create an object face, click the object face icon in the short toolbar. Select PCB and assembly under the group notes. Okay, click this one, object face, or you can see this, object face, but it's much easier. And then click what? I forgot. Select PCB and assembly. Okay, PCB, where's PCB? And then assembly. Control and click. Okay, accept. Show contours. Create. We can see that. It's really amazing picture. We have to change calculated this object. Apply. Done. We can see the highest temperature is under here. It's about 69 degrees of Celsius in heatsink, because this is the source of heat, so that's why. And then we can see the PCB here, all of the distribution of temperature. And then that's all for my online test. Hopefully what I did is right. And if you guys have any question, you can contact me or do comment under my YouTube channel in the comment section. Bye bye.